The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. Depending on where you're logging in from, one of those will sound just about right. Welcome back to another great episode of our Best Practices webinar series with 7SIGNAL. I see several of you have logged in early as usual. Thank you for doing that. If you would like to, please let us know where you're logging in from. If you are working in the office today, if you're working remotely from home, what part of the world you're logging in from, we'd love to hear from you. I am actually back in the Cleveland headquarters office today, and I am joined by a special guest, Chris Minton, today. How are you today, Chris?
I'm very well, thank you. How are you?
I'm great. Good to have you here. And as always, we're also joined by Jim Vada. How are you today, Jim?
Doing well. Good to be back on the weekly webinar.
Awesome. We missed you last week, so we're glad to have you back. All right, there. I see a couple of you dropping in. We have Lex joining us from Texas today. Thank you, Lex. Chris is also joining us from Texas.
Nice.
We
Nice.
have Germund joining us from Northern Norway. Thanks again, Germund, for being here. We have Olivier joining us from Vancouver in the office. And we have Kenneth joining us from Denmark. Thank you, Kenneth. All right, thank you guys for that. You can continue to drop that in the chat here, and we will go ahead and get started. So we are 7SIGNAL, the leader in wireless experience monitoring. And as always, before we dive into today's topic, we'll give a little history and a little background on who we are as 7SIGNAL. So we have a great topic here today, appropriate uses of spectrum analysis and network design. As I mentioned before, we are joined by Chris Minton today, who will be leading our discussion, and Jim Vada as well. And as always, I'm Kelsey Rizzuto, the marketing specialist here at 7SIGNAL, and really excited to dive into this topic here today. And throughout the presentation, if you have any questions or comments at all, just feel free to drop them in the chat panel, and we will cover them during Q&A. All right, a few announcements before we begin. For those of you who have joined us recently, these will all sound familiar, but just bear with me here. So we do partner with CWNP for every single one of our webinars. So if you're pursuing a certification, you are eligible for continued learning credits by attending these webinars. So if you'd like a certificate, just send us a message and we can easily send over a PDF via email. We also send out a 7SIGNAL newsletter every other Wednesday, the digital experience newsletter. So if you're not currently receiving that and would like to be added to our mailing list, go ahead and drop us a note here in the chat as well, and we can get you set up to receive those. Additionally, we host a product tour every single Friday at 12 noon Eastern, and you can go ahead and register at that link there, go.7signal.com/tour, and I'll go ahead and drop this link in the chat here if you'd like to register and get all of your weekly updates on Mobileye and Sapphirei. We additionally post our recording and our slides for every single webinar to our Twitter account, so those will be up there later this afternoon. So if you're on Twitter, give us a follow. If you're not, no worries. You will all still receive the recording of today's broadcast and the presentation slides in a follow-up email as well. And with that, we also post all of our recordings and our archived webinars to our YouTube channel. So today's will be up there later this afternoon, and you can go ahead and watch some of the previous topics that we've covered in the past as well. All right, a little bit about 7SIGNAL. We were established in 2007 in Helsinki, Finland, and we're now located in Cleveland, Ohio. We've hit a lot of major milestones along the way that we're incredibly proud of, such as the 1 billion data points that we're analyzing daily, in addition to the 5 million devices that we're monitoring daily as well. And with that, we also have 15 patents, which goes to show that the technology you see from us at 7SIGNAL, you're only going to see from us at 7SIGNAL. Now, to give you a little bit more background as to what makes us so different, if you look at your typical enterprise LAN infrastructure here on the right, you've probably got great tools, great technologies, giving you really useful feedback on the network, such as your Riverbed, Cisco, Aruba, AppNeta, and more. but we pick up where they leave off, giving you the view into the individual user's experience, not just the infrastructure view. And we'll start here first with Mobileye. Mobileye is a software agent that can be installed on the individual devices themselves, giving you that perspective from the outside in, giving you that full visibility into the user's experience. Mobileye can be installed on ultimately any mobile device, such as your laptops, your mobile phones, pickers and scanners, workstation on wheels, and more. And it can be installed on any macOS, Linux, Android, or Windows device additionally. And with Mobileye, a lot of us here are working from home and will continue to do so at least a couple days out of the work week. So with that user experience view, we can give you that perspective into your external home networks, optimizing your user experience from home as well. Which is incredibly relevant and crucial moving forward into 2021 and beyond. Additionally, we do have Sapphirei, which are the sensors for service level quality and RF visibility. And through this combination, you're really getting a full perspective as to what's occurring in your network that you just can't find anywhere else. All right, thanks for letting me run through our background on 7SIGNAL. Before we pass it over to Chris here, I will launch today's trivia question, and we will see how you guys do. All right, Chris and Jim, can you guys see this question?
Sure can.
Awesome. What is the first thing you do when you found a potential RF interference during a spectrum analysis walkthrough at a location?
Might be a little bit of a softball.
Seeing a few mixed responses here, but interesting. Okay, I'll give you guys a couple more seconds.
Yeah, a little tricky. You have to read all the possible answers.
All right. Give you one more second here, and we're going to close the poll. Let's see the results. How did we do today, guys?
That's right. 80% got it right, according to CWNP best practices. It's the measure twice, cut once approach. When you see something, don't do anything right off the bat besides document it, right? And then start with your process, right?
Awesome. Well, thank you, Chris, and thank you to all of you for answering today's trivia. With that, I will go ahead and pass our controls over here to Chris so we can dive in.
Fantastic. Thank you, Kelsey. So I'm going to show my screen here. Let me know when you guys can see it.
Yep, see your desktop.
Okay, perfect. Great. And just an audio check. Can you guys hear me okay?
Sounds good.
Perfect. Okay. So everybody, thank you so much for your time. This is going to be a really great webinar. It's a lot of great information, and super excited to be able to talk about it with you guys. I seem to make the longest titles for my webinars, so this one is just about the same as all of them. Appropriate uses of spectrum analysis and network design, right? And happy Cinco de Mayo to everybody. My name is Chris Minton. I am a sales engineer with 7SIGNAL. You can follow me at Twitter, and there's my LinkedIn as well. I've been in the business for 23 years now, and my career has basically in half the time I've worked as an engineer, and then the other half I've worked with vendors, and I've really just gravitated towards SaaS, cloud, security, and Wi-Fi. And just so pleased to be at 7SIGNAL. Actually, Jim, coming up very close to my second or 2 years. So it's gone really fast, and super excited to be here. And the certifications that I think that are important to this conversation is I'm a CWNA and DP as well. And that's enough about me. So let's talk about our agenda, right? 3 quick topics: what you can see, when you would use, and why you would use spectrum analysis in network design. And then we're going to have some Q&A. So let's start off right off the bat. What can you see with spectrum analysis and network design? And I'd like to start this off with a funny. This is Bill Murray, and this is Ghostbusters 1984. Probably some of you guys haven't seen this. I actually saw this in the theater. And I want to level set about spectrum analysis. So I'm setting the scene here. Sigourney Weaver's character saw a ghost and called the experts, which was Ghostbusters. And Bill Murray, being the foremost expert, is doing a scan of her apartment in Ghostbusters. And he has this really interesting tool. And the customer gets a little frustrated with Bill and says, "Is that thing even working? Do you even know how to use it?" And Bill Murray's response is, I think so. And that slays me, especially when we talk about spectrum analyzers, right? So spectrum, let's level set with what a spectrum analyzer is. And if you guys follow Keith Parson, and if you don't, I highly suggest you do. He does a lot of great information about spectrum analysis and different vendors and pros and cons. But he always starts level setting about what spectrum analysis is. And he starts at the very basic level. And I'd like to steal some of his words. And is that we're human beings. We see and hear in a certain spectrum. And Wi-Fi is radio frequency, it's RF. We don't hear it and we don't see it. So what we have done, and think about astronomy as well, is that we have taken a machine to basically say, listen to these frequencies that we can't hear with the common eye, or with the common ear, and color code it based on temperature, air quotes, right, on signal strength, and then give it to us in a way that humans can interpret what we're seeing. So with a grain of salt, that's what spectrum analyzers are, right? It is actually a machine with code, and everybody does a little bit different, that listens to the certain frequencies and certain bands and then reports the signal strength. Now, if there's anything that you guys could remember from this presentation, is the one thing I'd like you guys to walk away with, and I think it covers everything with spectrum analysis, all vendors included, is that you really need to focus on the time frame of the sample. Spectrum analysis is slices of time, usually averaged together. And it's going to be a reoccurring theme that I'm going to talk about in this presentation, but I'm going to talk about the four main uses, and you're going to see this in all three main topics. Channel utilization, channel width, channel centers, and our favorite, non-Wi-Fi interference. What is this, right? That's going to be some fun stuff that we'll talk about. So let's talk about channel utilization or duty cycle. Again, notice this right here. And I have a question. If channel utilization is 50%, is it time to move channels? Is it time to intervene? If you guys can see this down here, here's a person connected on one channel, right? Great signal strength on 2.4 on 6. Two clients are connected during the sample, but it's at 61% utilization. I'm curious in the Q&A chat, is this a good thing? Is this a bad thing? Well, let's talk about duty cycle, right? So duty cycle is basically a percentage. So, and let's also compare it to what the Wi-Fi medium is. So 60% of the time, this channel is occupied. Well, all clients in Wi-Fi are communicating, right? So they need to communicate. They need to get on the medium, transfer information, and hop off. Wi-Fi is a very polite medium, polite standard, saying, after you, after you, after you, right? So yes, it is a problem. So this is something that we're going to see in spectral analysis, and I think this is one of the values of having a spectrum analysis in your environment. Let's move on to channel width. And again, we haven't looked at spectrum analysis yet, but I'm just setting the theme here. So we all know the 1, 6, 11 on 2.4, right? These are, and again, we're North America, so don't worry about this guy, right? We're just talking about North America frequency. Sorry for our guys in other areas. But we have the non-overlapping channels, 1, 6, 11. We have a center frequency for 1, 6, and 11. So most of our great designs, in my opinion, should be in the width of 20 megahertz, right? So you'll notice over here, we've got definitely some signals happening and using 1, 6, and 11. But you'll notice, if I count this, 5, 10, 15, 20, right? 20 megahertz channel, center channel, right? So this is where we're at. You'll also notice, look at this fellow right here, all the way across, 5, 10, 15, 20, 25, 30, 35, 40, 40 megahertz channel, right? That's a bonded channel on 2.4 interfering with basically everybody here. So what does this mean with spectrum analysis? So in our first screen where we actually talk about what we can see is we have a line graph for spectrum analyzer, and we have two different ones. And there's going to be a little trivia question here about why they are a little bit different. In the 2.4 band, this is what we want to see. Our colleague Eric Camuli likes to say that this is a beautiful W, and it just resonates with me. If I have a AP client network, I've put a channel plan, and I am making sure that I'm using channel 6. How do you verify that? And I'll pose the question, could a AP say that it's broadcasting and working on one channel and it's actually broadcasting and working on another? And the answer is yes. We actually see it quite a bit. A lot of bugs and vendors, right? It's just code. But this is what you want to see. You want to see in spectrum analysis that in a pre and post environment, we'll talk about here in the next few slides, that if I am using channel 6, right, let's just look at our 2.4 center frequencies, right? I want to see that dip, right? And I want to see information. I want to see signal strength on both sides of it. And then I want to see a nice drop. If I saw this spike, right, in this area, what does that mean? That means that somebody's communicating on a non-overlapping channel, right? Or I'm communicating on a non-overlapping channel and not know that. So why the two different spectrum analysis graphs here? Well, I have two spectrum analyzers here. You'll notice that the signal and frequency, the X and Y graph, this goes back to my big shout out for looking at spectrum analysis, is before you look at any of the data, look at what you're actually looking at, because it slices in time and it's also usually averaged out, right? And we'll show some metrics how it skews over different time samples. But why would one Sapphire Eye, and then of course this is what we're using, or any spectrum analysis, have a better signal strength, right, than the other? And it's a real simple answer, right? It is physically closer to this AP, to this BSSID, right? It hears the signal strength. It is closer to it, so of course it has a stronger signal. But again, in line graph spectrum analysis, this is a great tool to confirm, where your channel plan, where your clients are actually working. And let's move that to the actual spectrum analysis, the waterfall. And what is going on right here, right? So let's talk about non-Wi-Fi interference. Again, another way of looking at data, before you even look at the data, notice my sample. So what am I looking at? I'm looking at the frequency. I'm looking at base speed, right? But I'm looking at a huge point in time, 1 day, 2 day, 3 day, 4 day, 5 day, 6 day, 7 day, 8 days. So before even looking at this and making a diagnosis of what's happening, you, me, all of us, we need to look back and look these days in time. That's 8 days worth of data that's averaged, right, from this device. Am I supposed to have information during, say the weekends or holidays? When are my clients actually in use? When are they in business? Why do I see something that is just always hot 24/7, 365? I mean, that's what this is, right? Why is it short and as a width, right? Finding non-Wi-Fi interference in some devices that are kind of outside the norm are usually really easy to spot, especially where you see just something hot all the time. Begs the question, is it supposed to be there? Is it not supposed to be there? Usual suspects, microwave, but only when it's microwaving. I don't know if that's a word. I actually did check the glossary, thesaurus. I couldn't find one, but everybody says microwave, but no one ever thinks, well, it's only going to have interference when the microwave is on microwaving, and then it's only going to have interference, for people in those frequency and basically on this location, right? Cordless phones, if we still use them, same thing. They kind of pop up all over the place. And then we have our newer usual suspects, industrial machines, security cameras, spy cameras, and it starts to bleed into if something's actually not Wi-Fi interference at all, but you can see it on spectrum analysis. Is it a Chromecasting? Does Chromecast actually confirm or fit the bill as non-Wi-Fi interference? Roku, Bluetooth. Can one Bluetooth mouse actually cause interference? How about a whole bunch of them in a call center with headsets, right, that are stationary? right? You can also pick up things like like hidden nodes or hidden SSIDs in the spectrum analysis. I have a great website at the end of this presentation that you can actually pick some criteria that you see in spectrum analysis, and you can get a good idea of what that device is that's actually broadcasting in your environment. So stay tuned for that. So let's move back to the topic about when you would use this. So I believe that you should use spectrum analysis before, after, and during, right? I believe it is a good time to have an example of this information, you know, as to whatever your business model is. I hope that I'm beating into the point that you can do a scan and you're only seeing what that is at that point in time. You're not getting any historical information. It is a great tool basically to look into the past, you know, and start to look at trends, but you want to make sure and think about your customers and your clients that you're actually looking at it. But let's talk about these four. We're talking about pre and post survey. That's pretty obvious. And then my favorite is continual monitoring, and then also using it as a troubleshooting tool. So PreSite Survey, this is really basic, as we know, you know, what is this, right? And just keep wanting to do that, right? So I've seen something automatically as an engineer, you're like, what's going on over here? So you'll notice, you know, there's definitely some non-space here. So I have a regular format. This is our office. These are our spectrum analysis, which are Sapphire Eyes. And I'm looking at one of them, and I've just done a scan over time just to see what's what, right? So I can start to make the decision before I install my APs of what the channel is going to look like, what the interference is going to look like. You know, can I use some channels? You know, what's going on, right? Moving on, after you install the APs, I think this is a pretty big miss, and I hope you guys are listening. Is that we see this as soon as somebody does a post survey and installs the APs and gets the RM or ARM running, away it goes, never to look at it again. You need to confirm that it's actually your APs, your controller, your environment is actually on the plan that you set it to. So again, this goes back to the example previous, is that I have my APs, you know, on a specific channel. I want to see that information. I want to see that working on that channel. I want to be able to confirm that, yes, this plan is right. If I'm moving channels, I'm using ARM, RM, you know, am I doing something, you know, that is proper, that's not actually hurting me? I'm not against RM or ARM. I think it's a great tool, but I have seen it in especially high dense environments where it just starts going crazy and just starts causing more problems than it actually tries to help. We have other webinars that talk about that. Suggest you guys check that out. But again, this is after the survey when I've installed, and again, this is this is best practices from certified wireless network professionals, is to make sure that your channels are and your APs are broadcasting and working on the channels that you selected. And then continual monitoring. And I think this is for the case of actually having some type of device, if you can, to look at the network and be there basically doing its job over time, because then you get great historicals and you can see things new. Remember, we talked about how Wi-Fi is an unlicensed, unbonded, anybody can use metric or standard, and things can change. So you'll notice here, you know, my RF can actually look very different from time to time. You need to take that into account when you're troubleshooting Wi-Fi issues, because it's so difficult to pinpoint, you know, is interference actually causing an issue, a digital experience issue with customers, and is actually the Wi-Fi issues or something else going on. You know, those non-Boolean issues, sometimes it's great, sometimes it's not. Right? That's when you start looking at that timeline, starting to get that information from spectrum analysis saying, hey, what's going on, right? So another one is troubleshooting, and this is the same data, but what I wanted, and this is for every vendor, but it's in different time periods of the same. So notice how different the coloring, just at the coloring looks, and then how some things always stay constant. So we have several days here. I believe this one's just 1 day, and then we have just a combination of a whole. I think this one's actually even 30 days or 2 weeks. right? So things look different based on the time slot. I know that's pretty self-evident to say out loud, but as engineers, when we see something, we automatically want to start zeroing in, and you always need to take a step back, especially spectrum analysis is the best practice, is to look more at your sample and what you're actually looking at, and then start to work either forwards or backwards from that. But that's a great thing that I have to keep telling myself in my daily business that I need to pay attention to the time period. So let's talk about again why you would use this, right? So this is the third, and you'll notice it's pretty much the same, right? Channel plan, continual monitoring, troubleshooting, and then Wi-Fi assurance. I want to stress this quite a bit with the waterfall. And this is a personal thing for my work, I like to go and confirm that what I'm being told by the AP, what I'm being told by other tools, is actually what's happening in the air. So I like to always go back and see, is my client, my Wi-Fi station, is it connected at the right at the right fizz, right? Is my NIC able to do the right fizz? And if so, can I do the latest and greatest, right? I'm not dropping down to N. I should be doing, AC. Am I using both my 2x2, right? Gets better data rates. And if not, why? Well, it's usually because of interference. What causes interference? Other Wi-Fi. How do I find what's interfering? Spectrum analysis. So I can start to go and look to say, hey, is something happening and causing this digital experience? And then also confirming that my channel plan is what it is. In my career at 7SIGNAL, I've seen many customers that we assumed the channel plan was X, and it turned out to be vastly different over Y. Not sure if you guys have seen that in your experience, would love to hear about it. But having the spectrum analysis is that check of you're being able to see that medium. I mentioned this slide right here about Wi-Fi assurance. Could be the same thing as monitoring, but it's all about digital experience. And again, this is the clients, the Wi-Fi stations, over a period of, I believe it's about, 24 hours? I think so. And these are client retries, and I put 7SIGNAL's definition of what a client retry is right here. And what's really interesting is that a decade ago, 50%, which I was reading about it actually even last night, was considered okay for client retries. Now it's 10 is best practice. So that goes back into how do you start to move into looking at spectrum analysis, right? That Bill Murray thing. What am I actually looking for? How does it work? Well, what causes client retries, right? From the client to the AP, it's usually, there's too much contention. Why is there too much contention? Let's start looking at the channel. Let's start looking at interference. Let's start looking at all this information, because what happens to our Wi-Fi stations when we get a lot of interference, right? We start to back down. The AP starts to back down. We start to run at a slower pace, or on sometimes even on another band, right? We'll jump if the SSID is in the 2.4 and the 5, and we're too far away, right? We'll drop to 2.4. That kind of stuff, things can start to pop up. So it does trickle. So again, spectrum analysis is great for not seeing client retries. Spectrum analysis is a layer one, right? It's a layer one medium, straight at the physical layer, but it shows you so much about, the lanes of your Wi-Fi plan, and if everybody's right, and if something is actually interfering with it. So I would like to stop right there and talk to Jim about some of this. And Jim has a couple of examples about actually looking at spectrum analysis and seeing an issue from spectrum that was a little unique. And Jim, I wonder if you could talk to these two issues here.
Yeah, thanks, Chris. So two different things here, and both of them show non-Wi-Fi sources of interference. And if you're not aware of these kind of things while you're doing your design, validating the design, before you do the design, it can really throw a wrench in things. So on the left, really busy 2.4 gigahertz band. and there's Wi-Fi operating on channels 1, 6, and 11. But there are two other non-Wi-Fi protocols operating in the band. There's Bluetooth, and you can see these really narrow band transmissions around like 24, 45, and up on the far right upper end of the band. That's where BLE does its advertising. And then when there's data to transmit, Bluetooth will frequency hop across the whole band. And so you see that wideband activity periodically there as well. So there's Bluetooth devices advertising, and they're transmitting, and they're using the whole band. It's true that Bluetooth has a Wi-Fi avoidance mechanism built in. But if Wi-Fi is using the whole band already, using channels 1, 6, and 11, there's only so much, avoidance that can occur. But the other thing I saw here, there are those, again, narrowband transmitters, but with much higher signal strength right in the middle of the band. And they look to be about, 3, maybe 5 megahertz wide. That's 802.15.4, probably Zigbee, or another wireless protocol that uses 802.15.4. So all this is happening in the 2.4 gigahertz band. And if there are, critical devices operating there because they're 2.4 gigahertz only, and that's just a constraint of the design, it's going to be a real challenge, and this is going to need to be addressed. So it really hammers home the importance of design, of having visibility into the spectrum while you do your design. On the right there, this is the 5 gigahertz band. It's actually just a look at Uni 1. Actually, sorry, that's Uni 1 all the way through Uni 2, so channels 36 through 64. And this was a really perplexing one, but I tracked it down during troubleshooting. We're actually looking at the duty cycle here of a transmitter, and you can see over time it's about 100%. So you can imagine just flipping a radio on, it's transmitting continuously. There's no listen before talk, there's no end of transmission, it's just sending a signal constantly. And analog devices are typically what do that. That is death to Wi-Fi, because Wi-Fi, like Chris mentioned, is a polite protocol. It has to listen before it talks, and it will not transmit if it detects an ongoing transmission from another source on the channel. So all the Wi-Fi devices operating on, about channels, 40 up to 44 or so, APs and clients simply are not transmitting. They're buffering frames, they're not transmitting, they're experiencing packet loss, they can't connect, they're disconnected. It's a disaster. So what this device was actually a cellular phone signal booster. So you might wonder, why is a cellular signal booster operating in the unlicensed 5 gigahertz band? Well, this was a device that had two components. So there was the outdoor receiver, not outdoor, but sort of external receiver you put near the window that would receive the signal from the carrier. And then there was this indoor component you put where you wanted better coverage. And the way they communicated back and forth was with some proprietary wireless protocol in the 5 gigahertz band. So extremely disruptive, and also makes the case that you do need to look at 5 gigahertz too. There can be ugly stuff there as well.
Mm-hmm. Mm-hmm. Wow, that's amazing, Jim. Thank you. Without spectrum analysis, how would that have been diagnosed, do you think?
Well, of course, the problem report came in as voice calls dropping, people can't connect, slow Wi-Fi. It's the same thing we hear every time there's a Wi-Fi problem. and you could go and experience the issues yourself. But without a spectrum analyzer, it's really just a guessing game as to what the underlying cause is. Because non-Wi-Fi devices are totally invisible to Wi-Fi devices. You have to have a spectrum analyzer to see what's going on outside of the 802.11 protocol.
My goodness, it's amazing. Thanks, Jim, for that information. That is something I never would have put those two together. You know, that's it's a cell phone booster. Wow.
Mm-hmm.
Right? That's causing a drop voice. That's some irony in it.
You know, yeah, there's a good joke in there, isn't there? Cellular versus Wi-Fi.
So again, just the conscious time, I just want to wrap this, up about troubleshooting and assurance. It's to Jim's point. It's a great way to diagnose and then make sure that your space, your environment is behaving like you've programmed it to. And then also if people are interfering with it or if other devices are interfering, that's the tool. It's going to save you a ton of time, a ton of frustration, and having Wi-Fi and it's hard to solve problems. That is when spectrum analysis is a great tool. And then pre and post, making sure that things are together, and then just continually monitoring that. We'd like to see how things change in the air. I wanted to wrap up with some tools for you. Again, these were the topics that we hammered home. But I had found a great tool, and if you guys have seen this, I'd like to know your comments on it. But every device that's registered with the FCC, like I'm just holding up my cell phone, it has to be in a database, and you can actually search on that device by its FCC number, and you can also put information in this search engine. So why, right? What's why, Chris, why are you showing me this? Well, let's say, like Jim had mentioned, I've got something that's coming in and out and is only using like 3 megahertz wide or 1 megahertz wide, and it's always at this frequency. Well, you can start to find out what that device is, because again, it's invisible to non-Wi-Fi devices. It's not going to tell you by a tool or anything that says, oh, I'm the new digital display here at headquarters. You can type this information into this database and start to find and get really close to what device is actually interfering. And I've had some luck with it at 7SIGNAL. We've found TVs that were broadcasting Wi-Fi. Again, they weren't supposed to. It was turned off. We couldn't figure out what it was. We didn't have the MAC address for it, but we went and looked at its frequency and added some other stuff. And I was like, well, do you have a so-and-so television? Like, oh yeah, it's right here. How long has it been there? Oh, since this problem started, right? It wasn't that easy, but so that's a great tool for you. And then I wanted to throw just a couple of tools. These aren't spectrum analysis devices in the sense. I'm not going to go into a dissertation on who's better, pros and cons. Spectrum analysis, there's quite a bit out there. Again, it's really to what fits your needs. But I like the channel visualizers, and there's a free one for Windows, which is WinFi. There's a paid version for it. I paid for it. I was like, wow, this is great. I did the same thing for Mac for Wi-Fi Explorer Lite. I use these all the time, and it's just a great little visualization. Again, this is a nice to have, but again, you would only use this when hey, is something up? I'm just popping up. I'm seeing what it is now, but I'm not going to get that historical. I'm not going to get deep. I'm not going to get spectrum analysis. I'm just going to get really just channel information. But those are some great little tools. Hopefully that you have, and this will be uploaded if you wanted to go to that link. And
yeah, Chris, one thing too about Wi-Fi Explorer, the Pro version allows you to connect a USB spectrum analyzer like what you can get from MetaGeek. So you can see some rudimentary spectrum analysis there.
That's right. Thank you, Jim. I forgot all about that. Yeah, I was just thinking of the free stuff. But the great tools. I mean, really, really interesting. So that is it for the presentation piece. I'm going to stop sharing my screen. And if there are some questions, I will do my best to answer. And it
Yeah,
looks
let
like,
me let me bounce some of these off you there, Chris, and welcome anyone else that has a question to drop it in the Q&A panel. He had a question or just a comment from Frank as we were going along. He says, I suspect there was a Zigbee gateway in one of the spectrum charts we saw, and I think he was right. We see Zigbee more and more among our customers and people evaluating our gear, like the Sapphirei with a spectrum analyzer. And sometimes it's a complete surprise. We didn't know we had any Zigbee devices. It perhaps was a project done outside of IT. But certainly something growing.
It's the new shadow net, right? Is that what they call it? The shadow network, or shadow IT? Yep.
Yeah. Yep. Well, there's a lot of other groups that want to have wireless devices, and they can sneak something by without going through IT. Sometimes they'll try. Question from Yermund, and thanks for the question, Yermund. He says, getting into kind of the semantics, really, but what is the difference between duty cycle and channel utilization?
Good question. I'm going to say it's all based on time samples, but I'm going to defer to the CWNE on the chat here.
They are closely related ideas. Sometimes you'll see them used interchangeably, but channel utilization is specifically measuring the utilization of a 20 megahertz wide Wi-Fi channel, and thinking about it in that context. Duty cycle doesn't have a channel width associated with it, so it's really just the percentage of time a transmitter is transmitting. So we often see duty cycle used for non-Wi-Fi sources of interference that might be really narrow band or wide, and just talk about the duty cycle independent of the channel width.
You can see the difference between a CWNA DP answer and a CWNE. I was like, well, it's something with time.
Wayne asks, are there any good layman tools for spectrum analysis? I think we covered that in the slide there. Check out WinFi and Wi-Fi Explorer for sure. Anusha, hope I got that right. Question is, when interference happens during uplink traffic, how do Wi-Fi APs change channel when non-Wi-Fi devices are involved? So I think the question is, how does an AP react in terms of channel changes when there's the presence of non-Wi-Fi interference?
Right. So the Wi-Fi second question is it won't, because it doesn't see it, right, Jim?
Most of the time, that's correct. So you got to sort of hope. It may just sit there. I mean, these are the channel changing algorithms are proprietary. So
that's right. So first question, yep.
So the AP may just sit there, or it may say, hey, the retries on this channel are really high. I have no idea why, but I'll just switch channels and see if that's better.
But it won't make the connection between, hey, there was a non-Wi-Fi device in my channel space that was causing that interference, and so I'm going to change channels. And then it also wouldn't just be able to identify, right, that there's non-Wi-Fi in my channel, right? So I'm gonna move to something else, right?
Yeah, an 802.11 radio can't do that. So if you have a expensive enterprise AP that also has a spectrum analyzer built in, then that's a possibility. But not every AP, of course, has that feature.
That's a good question.
Yeah. Couple more questions here. Question from John. So other than removing a Zigbee device, how do you resolve the interference issue? Can things be configured to be compatible in or around a Wi-Fi environment? So good question, John. And this is where it's helpful to have, a little bit of understanding of some of those non-Wi-Fi protocols that share the band. So Zigbee, uses much narrower channels, and some of them kind of can fit in between the 3 non-overlapping channels that Wi-Fi uses in 2.4 gigahertz. I think channels 25 and 26 in the Zigbee world are distinct and, have some frequency separation from up above channel 11. So you can, if you can configure that Zigbee system to run on a certain channel, you certainly can have it avoid your Wi-Fi. Or you can say, well, I have a lot of Zigbee and I need to use several channels, and say that means I'll remove one of the 3 channels from my Wi-Fi channel plan in 2.4 gigahertz and use that spectrum just for Zigbee. So you still can do some frequency, some spectrum planning between the protocols to prevent interference. Yeah, maybe one last question from Olivier, who says, and good question, what signal threshold do you usually use to calculate utilization or duty cycle? SNR of 4 dB? And does it depend on the situation?
Ooh.
Yeah,
That's a good question.
It definitely depends. I think it really, well, it depends on the context, but first it depends on the hardware. So different hardware has, greater or less receive sensitivity, just like a Wi-Fi radio, and can detect signals that are higher and lower than others. But it also, but part of it is, in a Wi-Fi context, well, when do you even care, right? If there's a super quiet signal that's not going to interfere with Wi-Fi, big deal.
Yeah.
And so the 4 dB of SNR, that's a pretty good threshold to really start, considering the impact of a source of non-Wi-Fi interference, because that's when you're going to start tripping the clear channel assessment for your Wi-Fi clients.
Yep. It's a note it and identify it first, right, before starting to working around it. And like you said, Jim, do you even need to, right? It goes right to our trivia question. What do you do when you see it first, right? Do you automatically start attacking it, or you just do nothing, or just make note of it? And
I just start attacking it, and then I stop myself and say, oh, I need to save these graphs.
I usually panic and run.
A good strategy. All right, I think that about wraps it up.
All right, awesome. Well, thank you so much, Chris, for leading today's topic. Really interesting and great to hear all of the great questions today from you all. And of course, as always, thanks, Jim, for being here too. And thanks for giving us 48 minutes out of your workday today. We love connecting with you every single week on these webinars, and hope to see you at next week's webinar. So thanks, everyone. Thanks, Chris. Thanks, Jim.
Thanks, Chris. Thanks, Kelsey.
Thank you, guys. Bye.
Bye, guys.